According to plate tectonics, diverging boundaries exist where plates are moving apart. Most diverging boundaries coincide with the crests of submarine mountain ranges, called mid-oceanic ridges, Figure 111. A mid-oceanic ridge is higher than the deep ocean floor, Figure 1 and 12, partly because the upward flow of hot mantle material pushes the lithosphere upward, and partly because the rocks, being hotter there, are less dense. Tensional cracks develop along the ridge crest, Figure 1 and 13. These cracks tap localized magma, molten rock chambers in the underlying asthenosphere, and the magma squeezes into fissures, cracks through the lithosphere. Some magma erupts along the ridge crest, and the rest solidifies in the fissure. Continued pulling apart of the ridge crest develops new cracks, and the process of filling and cracking continues indefinitely. Thus, new oceanic crust is continuously created at a diverging boundary. Not all of the mantle material melts. A solid residue remains under the newly created crust. New crust and underlying solid mantle make up the lithosphere that moves away from the ridge crest, traveling like the top of a conveyor belt. The rate of motion is generally 1 to 10 centimeters per year, slow in human terms, but quite fast by geologic standards. A diverging boundary at a mid-oceanic ridge. Hot asthenosphere wells upward beneath the ridge crest. Magma forms and squirts into fissures. Solid material that does not melt remains as mantle in the lower part of the lithosphere. As the lithosphere moves away from the spreading axis, it cools, becomes denser, and sinks to a lower level. As the lithosphere moves away from the diverging boundary, the material slowly cools. As it cools, it contracts and becomes denser. The contraction of the lithosphere and its slow sinking, because of the increased density, cause the floors beneath oceans to deepen away from ridge crests. The top of a plate may be composed exclusively of oceanic crust, or include a continent or part of a continent. For example, if you live on the North American plate, you are riding westward relative to Europe because the plate's diverging boundary is along the mid-oceanic ridge in the North Atlantic Ocean, Figure 110. The western half of the North Atlantic seafloor and North America are moving together in a westerly direction relative to the mid-Atlantic ridge plate boundary. A second type of boundary, a transform boundary, occurs where two plates slide past each other. The San Andreas Fault in California is an example of this type of boundary, and the earthquakes along the fault are a result of plate motion. The third type of boundary, one resulting in a wide range of geologic activities, is a converging boundary, where plates move toward each other, Figure 114. If one plate is capped by oceanic crust and the other by continental crust, the less dense, more buoyant continental plate will override the denser oceanic plate. The oceanic plate sinks along what is known as a subduction zone, a zone where an oceanic plate descends into the mantle beneath an overriding plate. The entire oceanic plate becomes increasingly hotter as it descends deeper into the earth. In the region where the top of the subducting plate slides beneath